Alright, today's lesson was all about inverse functions. There's some key properties here I want to review with you. So first of all, inverse functions. So let's say we've got two functions, f and g, and if they have this property, this goes back to our previous lesson when we did compositions. F of g of x equals x, and g of f of x also equals x. So they basically just undo each other, and it doesn't matter which way you go in this case, and you get x. If that's the case, then the function g is the inverse of f. We could say f is the inverse of g as well. It can be denoted as this f. It looks like to the negative 1 power, but that's just how we represent the inverse. And we can say these two functions are inverses of each other. Okay? Well, that gives a special property. Let's say we've got this function g of x equals 17x minus 5. What is the value of the inverse of g composed with g of 35? Well, notice I don't even know what the inverse of g is. We could find that. We're going to do that here in a few minutes. But it doesn't even matter. Functions inverse composed with itself, they wipe each other out, and you get 35. Okay? So what if I've got some function? In fact, let's do this same one. What if I did g of the inverse of 297? Well, I don't even think about it. It's 297. As long as these things fit in the domains of these functions inverse, and you're going to have to worry about that right now. These just wipe each other out, and you get the same number you started with. So that's a pretty cool property. Okay, let's keep going. The domain of a function equals the range of its inverse. That's an interesting property. The range of the function equals the domain. So they just trade places, basically. Domain becomes the range, range becomes the domain. Well, that causes some interesting properties. So I put it in red here. The graph of an inverse is a reflection of its original function in the line y equals x. So it's like a mirror image there in the line y equals x. Okay, that has a kind of an interesting property as well. So if the point AB, whatever AB is on F, then just switch them, right? Domain A becomes the range, range becomes the domain, lies on its inverse. So let's just put a numeric example of that. So if the point 513 is on the graph of some function, then the point 13,5, just switch them, must be on the graph of its inverse. Hopefully that makes sense. Okay, so here's an actual graph type of thing that you'll want to be comfortable with. So they give us a function here, and notice they put this dotted y equals x right here for us. Which of the graphs is the inverse? Well, it has to be reflected in this line right here, y equals x. So which one of these does that? Well, again, if you just imagine y equals x there, you could imagine sketching it into yourself. Which of these is a mirror image in that line? Well, clearly it's letter A, right? And so that's how you do problems like that, how you approach them. Okay, how about this one? Let's actually talk about finding inverses. Now, you've already done this in the lesson, so this is just a quick recap. Here's the key. Reverse the variables, so your x and y just trade places, and that's what they're showing here in this step. And then you rearrange the equation, you get y by itself. Okay, you're just rearranging it. So here they added 12 over, then they divided 5. This equation are inverses of one another. Okay, let me do one for you. Find the inverse of this function. Well, I'm going to rewrite it like this. Y equals 2/5 x minus 7. All that f of x means it's a function, but that's our output. So we can put a y there. So remember what we do? I'm going to put a line to divide here. Switch your x and y. So x equals 2/5 y minus 7. And now we want to rearrange and get y by itself. So let's add 7 to both sides. So x plus 7 equals 2/5 y. And now let's get y by itself. Let's multiply 5/2 by both sides, okay, or divide by 2/5, however you want to think of it. So I'm going to do 5/2 times both sides, and let's see what we get. So of course these would divide each other out. So y equals 5/2 of x plus 7. It'd be fine to write it like that, or you could do 5x plus 35 all over 2. However we want to write it. But there is the inverse, okay? So hopefully feel pretty good about these things. You ought to be in good shape on our little practice quiz today.